Welcome. So we're going to answer this following question, and it's really a great one. It says A and B are events from a sample space such that the probability of A is equal to P, where P is greater than 0. The probability of B given A is equal to M, and the probability of B given A complement is equal to N. A and B are independent events when which of the following are true. Now, this is where you got to think through what does it mean for events to be independent. This is where a little example might be useful here. If I have a dice, okay, and I said, what's the probability of me rolling a dice if it's raining outside and getting a 6? So rolling a dice and getting a 6, what's that probability? Well, you'd say it's 1 in 6. Whether or not it's raining outside has no bearing on it at all, right? These are independent events. Me rolling a 6 has absolutely no relation to whether or not it's raining outside. So if we come over here and kind of keep this example in our minds, the probability of B given A, if these are independent events, is simply going to be the probability of B. So the probability of B is equal to M. So to use our example for a second, the probability of rolling a 6, given that it's raining outside, is still 1 on 6. It raining outside has no effect on it at all. Well, let's come over here now. The probability of B given the complement of A is equal to N. Well, this is kind of like saying, what's the probability of rolling a 6 if it's not raining outside? Well, they're independent events. Whether it's raining or not raining doesn't impact it at all. This too is just the probability of B. So that means the probability of B is equal to N. And hopefully you can see the probability of B is M, the probability of B is N, M is equal to N. And just like that, we've answered the question. So this really is a question that you could answer in mere seconds if you truly understand what's going on here. Now, hopefully you can just get that and just keep going on. That's really what we want you to be able to do. But there is another way to answer this question, and it is mind-numbingly long, and it really relies on people being too formulaic. So it's really important that you're not too formulaic. So for instance, I think a lot of people, and this is now, so stop for a second. I'm now going through the bad way to answer this question. This is the good way to answer. I'm now going to go through the bad way of answering this question. Okay, and this is kind of just for fun. If you want to click off it now, you can go away if you want. Okay, what's the bad way of answering this question? A lot of people would say, well, I know that independent events means the probability of A given the probability of A intersection of B is equal to the probability of A times the probability of B. So as you can see, they're treating it very formulaically. They're not considering the fact that we've been given some conditional probabilities that really speaks to independence. They're kind of just going straight for the formula. And then they start saying, well, how can I use this formula to answer my question? Because even though I know what A is P, I don't know what B is. Now, I've been given conditional probability. The only way to get what B is going to be in this example is to actually do the following. It's to do this. Now, I've got A or not A. Now, that's going to be P or 1 minus P. And then B or not B. Now, I know the probability of getting a B, given that I've got an A, is M, which means this is 1 minus M. B, not B. The probability of getting a B, given that I've gotten the complement of A, is N, which means this is 1 minus N. If I therefore want to get what the probability of B is going to be, I'll multiply across this branch, and I'll multiply across this branch, because both of those get me B's, and then I will add those together. So that means I'm going to get P times M is PM, and I'll get 1 minus P, and I'll multiply that by N. That's going to get me N minus NP. Therefore, the probability of B is going to be PM, we'll say PM plus N minus NP. Okay, perfect. So now we can come up here and we can put that in. So this is going to be PM plus N minus NP. And we know that this is going to be equal to the intersection. Now the intersection is just this, PM. Okay, now once we're here, we can say, all right, PM is going to be equal to, now this whole thing is being multiplied. So it's going to be P squared M plus NP, or PM, let's put the P's in front, PN, and then I'll get minus P squared N. Okay, what would we do next? Well, you might think, well, there's a P everywhere here, so let's take a P out. PN. Then once I've taken a P out, this P will cancel with this P. And now I'm left with m is equal to pm plus n minus pn, you can already see how stupid this is. And this is all because we're relying on using this formula. And also kind of thinking, well, I need to use this p information here. We didn't use this p information, did we? We just did it anyway. All right. We're continuing to go on here. What would I do next? I would probably get everything with m on one side and everything with not the other. Then I would take m out, 1 minus p. I would take n out, 1 minus p. Would you look at that? They cancel. Which means I'm left with, wow, m is equal to n. And that's what, woo, and that's what we got right here. So this is very silly. But now you can kind of see the different ways of going about this question. A really great question there, and shows you the importance of being able to answer things quickly and not relying upon, just always relying upon one formula. You need to be able to think through a question and say, all right, what's the best way to answer this question? Get rid of that. We don't need that. We don't need that. That's all you need to answer that question. Hopefully you found this helpful and a bit fun as well.